Okay, this is section 8.4 z-test for the proportions. So test proportion using the t-test. Okay, so test the mean using the t-test without knowing the standard deviation population. But this is a test proportion using a z-test. Okay, so hypothesis test involving the proportion can be considered as a binomial experiment when there are only two outcomes and probability of the success does not change from a trial to trial. And we call that the mean is mu equal to n times p, and the standard deviation is sigma is square root of n times p times q for the binomial distribution. A normal distribution can be used to approximate the binomial distribution when the NP is greater equal to 5. Another n times q is greater equal to 5. The standard normal distribution can be used the hypothesis for the proportions. So this is actually the test statistic formulas. And then p hat is from the x divided by n. So p is the population proportion and the n is the sample size. Okay, and then the formula is derived from the z-score, which is x minus mu equal divided by sigma, which is the population standard must be given. And then substitute by the mu equal to np, and the sigma is n times square root of n times p times q, and divided the numerator denominator by the n. So assumption for the test proportions, the sample must be random sample. And then condition for the binomial experiments are satisfied. N times p is greater equal to 5. Also, n times q is also the greater equal to 5. Alright, so sorry about that. Alright, let's do the problems. So, cesarean babies. A report state that 21% of the babies are delivered by the cesarean section. Researcher believes that the percentage is less than 21% in a larger hospital in his hometown. He randomly selected 50 newborn infants and found that the A were born in cesarean sections at the alpha equal to 0.01. Is there enough evidence to support his claim? Alright, so we need to find the p hat, which is x over n. So x is 8 over 50, which is about 0.16. And then the p is 0.21 from the 21%. And also q is subtract from the 1 minus p, which is 0.79. So null hypothesis is a p equal to 0.21. And then h of 1 is p is they say less than and 0.21. So there's a critical value that a alpha equal to 0.01, which is this is a left tail. And then we are looking for the critical values, which is we are using the z-score. So for the z-score, so if you go to the table formulas, and then if you look it up here, and then you will see as we have to use a z-score this time. Okay, so from the alpha equal to 0, we are looking for the alpha equal to 0.01. So we are looking for the 0.01, 0.01, 0.01 that is close to the hold on a second. Yeah, I think that this is a close, isn't it? 0.01, right? Okay. Because alpha is 0.01, so this is kind of area. 0.0099 is close to 0.01, right? Okay, so go back to here. Oh, yeah, we need to find the z-squared. So which was, it's going to be the z-score was the negative, and about 2.33. So which means it's a left tail. So negative 2.33, which is this is the area of the 0.01. Okay, so we found the z-score as a critical value. Okay, and then test statistic, which is a z equal to p hat minus p over square root of pq over n. So p hat is 0.16, subtract the 0.21 over 0.21 times 0.79 over n equal to 50, which is about negative 0.868. So, which is, here's a 0, right? So, it's about here, right? So, this is going to be the negative 0.868, which is not in the critical region. So, what we need to do is we cannot reject it. So, do not reject the null hypothesis. Okay, so what do you do is there is not enough evidence to support the claim. That the proportion of cesarean birth is less than 21%. Alrighty, let's do the next problem. Okay, so this time I think I'm going to use a p-value method, okay? So the attorney advertisements. So an attorney claims that more than 25% of all lawyers advertise. A random sample of the 200 lawyers in a certain city shows that the 63 had used some forms of advertising. At alpha equal to 0.05, is there enough evidence to support the attorney's claim? Use a p-value method this time, okay? So, null hypothesis P is about 0.25, 25%. And then it also says P is greater. Okay, so they said that there's a more than 25%, so 0.25, which is a claim. P hat, which is x over n, so there are 63 said that from the 200, which is 0.315. So P is 0.25, which means Q must be subtract P from 1, so 0.75, okay? So let's get the z-score. So P hat minus P over square root of PQ over N. So P hat is 0.315, subtract P 0.25 over P times, which is 0.25 times 0.75, and divide by 200, which is come out as 2.12, okay? So I need to actually see the area. So if I use a normal graph, which is, this is about the 2.12. So I'm looking for this area. How much is this area? Okay, so let's go to the table to see. So what it is, okay. Erase that. So I want to use 2 point, so it's a positive, so 2.12. So 2.1, and then 2.12 is right here. Okay. So this is okay. But the thing is, this is about the area of the right side. So this is actually this place is 0.9830. So in order to find it, you need to subtract 1 minus 0.9830, which is 0.0170. So now p-value for the right tail is 0.0170. Is that the less than alpha, which is alpha is 0.05? So compare. Yes, it is, right? So we just reject the null hypothesis. Which means there are enough evidence to support the attorney claim that more than 25% of the lawyer use some form of advertising. Okay. All right, let's do the last problem. OBC young people. A researcher claimed that based on the information obtained from the Centers for Disease Control and Prevention, 17% of the young people aged 2 to 19 are obese. To test this claim, she randomly selected 200 people aged 2 to 19 and found that the 42 are obese. So at alpha equal to 0.05, is there enough evidence to reject them? So we can use either one. So, but I'll show you both ways because this is actually the two cases. So first of all, the hypothesis of P equal to 17%, which is a claim, and then the null hypothesis is going to be P is not equal to 0.17 because that's what they said, but let's see, it's going to be different from the 17%. So the critical value, which is at alpha equal to 0.05, which is this is a two-tail. So we need to find alpha over 2, which is 0.05 over 2, which is 0.025 to use, okay? So which means we need to find the z-score. That is, one side is area of the 0.025. Other side is area of the 0.025. But it's a symmetric. So if you find the z-score of this one, and then this is going to be just a positive. Okay, so negative positive. Okay, so let's go to the from the table. So that's clear. So I need to find the get closer to the 0.025. So 0.025. Let's go here. So 0.0. 0.025, okay? So 0.2525. Oh, right here. Oh, okay. So we got it here, right here, right? So the z-score is going to be here to here, right? So one is a negative 1.96. So negative 1.96 is going to be positive 1.96, okay? All right, now test statistic, which is a z equal to p hat minus p of square root of pq over n. Plug it in. 0.21 minus 0.17 over p is 0.17 times by 0.83 divided by 200, which equal to 1.51. So 1.1 it goes where? Still less than here, 1.51, isn't it? So it's not falls in the critical region, so we do not reject the null hypothesis, which means there is not enough evidence to support the claim that 17% of young people ages are, which is from the 2 to 19, are obesity. Okay? All right, now let's get to the p-value approach here. So p-value from here, which is we are looking for the, we are actually using the z-score. So 1.51, okay? So we are using the 1.51. So let's see. So go to negative, okay? Yeah, because that's the, oh, sorry about that. 1.51, negative 1.51. 1.51, which is this number. Okay, so that's the area. So we're gonna get twice of p-value, which is 0.0655, and then becomes 0.131, and then compare with the alpha, which is 0.05. Is it true? No, right? That's why we need to do not reject it. So you go back to do the exactly the same way. All right, thank you for listening.